So we've been taking derivatives using the power rule, and someone might say, well, that's all fine and good, but what do you do if the function is something like 5x to the fourth? How do you deal with that 5? Well, you're still just going to use the power rule. And how it works is the derivative of f, in this case, would be equal to 5 times, I'm going to drop the 4, and decrease the power by 1. So the derivative of 5x to the fourth is 20x cubed. And I can just keep going. If I wanted to take the second derivative of x, well, what's the derivative of 20x cubed? I'm going to drop the 3, 20 times 3, and decrease the exponent by 1. Now I've got 60x squared. And I could even find the third derivative. Right, so what's the third derivative of x? I'm going to drop the 2. So 60 times 2. Decrease the power by 1. I've got a linear function, right? 120x. I can find the fourth derivative of x. And just keep going. And what's the derivative of 120x? It's just 120. Because the slope of this is a linear function, its slope is 120. Another way to think about it is this is x to the first. If I drop the 1, 120 times 1 is 120. That would give me x to the 0 when I decrease the power, and anything to the 0 power is 1. I can go even further with this function if I wanted. What is the fifth derivative of x? And as we've seen, the derivative of a constant is always 0. And it's just going to keep being 0 from here, because now all I have are horizontal lines at 0. Now, someone may say, okay, well, that's all fine and good, but what about things that are more complicated, like some function, it's quadratic, x squared minus 3x plus 4. Well, this is pretty easy, because you're just going to look at the derivative of each individual piece. What's the derivative of the entire function? Well, I'll start with the derivative of x squared. Drop the 2, decrease the power by 1. What's the derivative of negative 3x? It's just negative 3. What's the derivative of my constant 4? It's 0. So the derivative of x squared minus 3x plus 4 is 2x minus 3. And this, 2x minus 3, is an expression for the slope of the tangent line at any x value on this quadratic. That's how you can express the slope of the tangent line. We could have a problem with something like this. I've got a function f of x equals 3x to the fourth plus 2x cubed minus 7x. And what I want to know is, what is the equation of the tangent line at x equals negative 1? Well, there's two things I need to know to come up with the equation of a line. I need to know a point, in this case when the x value is negative 1, and I need to know the slope of my line. Well, the point's easy to come up with. When x is negative 1, I can find the y value by substitution. 3 times negative 1 to the fourth plus 2 times negative 1 cubed minus 7 times negative 1. This leaves me with 3 minus 2 plus 7, which is 8. So my tangent line to the curve intersects the curve at the point negative 1, 8. That's the point of tangency. Now the slope is related to the derivative. What's the derivative of my function? Well, by the power rule, it would be 12x cubed plus 6x squared minus 7. And what I want to know is, what's the value of the derivative, or what is the slope at x equal to negative 1? So 12 times negative 1 plus 6 times positive 1 minus 7 would be negative 12 plus 6, negative 6. Negative 6 minus 7 is negative 13. There's my slope. So now I know a point, and the slope is negative 13. So what's my tangent line? Well, by point slope form, it would be y minus 8 equals negative 13 times x plus 1.